I've been doing a series of reality videos. This one is part 3 of time-lapse proves reality. Now in part 1, I show you how a sunrise works better on a flat earth. Now in part 2, I show you how the sun actually works on a flat earth. And this is part 3, the Analemma proves reality. How an analemma works is you take a picture of the sun at the same time every day, and the position of the sun makes a figure 8 shape in the sky. Here's an analemma on a globe. Now just looking at it, does it make any sense to you? Isn't it a little bit fishy that they stopped putting them on a globe a while ago? I wonder what the reason is. Okay, so let's see what mainstream has to say how the analemma works.
Because we're in motion around the sun, but because sometimes we're traveling faster and sometimes we're traveling slower. Those conspire to make a figure 8. And that figure 8 is called an analemma.
So apparently the sun speeding up and slowing down causes the figure 8 analemma, although I've never seen it animated anywhere. As for me, I can see a few problems with the Earth accelerating and decelerating. If the Earth is accelerating and decelerating, how does the North Star say lined up? That doesn't make any sense. Does the whole Milky Way galaxy accelerate and decelerate to keep the North Star lined up? If the Earth accelerates around the sun, what would cause it to decelerate? Doesn't an object in motion stay in motion? What would cause it to decelerate? Is there more gravity on the other side of the sun? Let me show you something that I think makes more sense. Here's the analemma on a flat, non-rotating, non-accelerating, not decelerating flat Earth. Now you can see the analemma is small on one end and larger on the other end. Now on the flat Earth model, the sun makes a smaller circle on one end, and as it moves away, it makes a bigger circle. It would change the size on the other end. So it makes total sense. Now being that they're two different sizes, kind of indicates to me as the sun goes around, not only goes in a circle, but as it moves away, it actually climbs up. It actually climbs up as it moves away, which would cause a different size analemma. So you can see it makes total sense on a flat Earth. Now, a lot of people say to me, hey, Anthony, how does the sun work on a flat Earth? How does it set? That doesn't make any sense. Okay, let me show you a model that I put together. Okay, so we got our camera sitting here, and we're going to shoot across the top of this flat granite table. And what we're going to try to do is going to get this flashlight to set like the sun. So let's turn on the recorder. And now we're going to slide the flashlight back. Now notice on the top right corner you can see the sun setting. The flashlight setting. There you go. Okay, let's go back down to the camera. Now, just in case you thought the camera's set too low, let's zoom in and take a look. You zoom in, and there's the sun again. So there you go. The angular size shrinks, so it works fine on a flat table. I'm guessing the sun can do the same thing. Okay, now let's move over to our flat Earth model. Now, on a flat Earth, the sun goes around a circle, and the sun lights up about half the Earth, or a little bit more. Now, let's get down to ground level here. Now, the sun, I put it on a little pedestal, so it'll stay the same height. Now, I'm going to show you two things on the same model here. Okay, the first thing is how the sun sets on a flat Earth. Okay, you can see this would be, let's say, in summertime, the sun's like over your head. Okay, so now as the sun moves away from you in a circle, it gets farther away. My arm's not long enough, it'll just set. Just like I showed you on the table. The only thing is, the sun is like local and not millions of miles away. It only has to travel a few thousand miles to set. Okay, so that's the first thing I want to show you. Now the second thing is, let's say on the analemma, let's say you're at summertime, you're at noon, sun's over your head, take a photo. Now every day, because the circles are moving away from you, Every day the sun's going to get lower in the sky at noon. So, and then when you get to the wintertime, here's the bottom of your analemma. So, you can see it makes total sense. And check this out. When you're in Montreal, which is right here, near the smaller ring, you're going to see the analemma this way. This is the smaller ring here. It matches the smaller ring on the inside. Now, when you're in Chile, which would be here, now you're going to see the analemma this way, because they're bigger rings towards the outside. So you would see the bigger part of the analemma towards the top. It makes total sense. And in closing, I'd like to say that I don't think the sun is some big planet with heavy mass flying through space, millions of miles away. So here on Earth, the ground is negative and the air is positive. And there's a positive voltage. For every 100 meters you go up, it's 10,000 volts. So I imagine where the sun is, there's a crazy amount of voltage. So the sun is probably a plasma arc or an energy field or an energy ball that moves around freely because it doesn't have any mass. Light doesn't have any mass. So it can move around as designed by a designer. I think if you pay attention, you can see the sun's not that far away.